Welcome to Royal Chemistry Park. In the previous videos, we have discussed the elimination mechanisms E1, E2 and the factors affecting the mechanisms. Also, we have seen the E1CB mechanism. In this video, we are going to see the comparison of E1, E2 and E1CB eliminations. I am Dr. K. Rajarajan, Associate Professor and the Head of the Department of Chemistry, Raja Sarfoji Government College, Tanjavur. Now let's get into the lesson. The E1 elimination, where the leaving group departs before protons, whereas in E1CB mechanism, the proton goes off first and then the leaving group departs. But in E2 mechanism, where both the groups leave simultaneously. This is the distinguishable fact among the three mechanisms. However, there are some elimination reactions which do not follow any of the above three mechanisms, but somewhere in between. For example, the leaving group departs just before the proton. These are examples of E2 with a little E1 character. Now let's talk about the orientation of double bond. When the secondary or tertiary alkyl halides undergo elimination, a mixture of olefins is the product depending on which carbon loses the proton. In such reactions, there is a preference for the loss of the hydrogen from the adjacent carbon having the fewest hydrogens. So the most highly alkylated olefin is obtained. This is what called as Zaitsev rule. E2 elimination in quaternary ammonium hydroxide occurs with the removal of the most acidic hydrogen. This leads to the formation of least substituted olefin because the primary carbon ions are more stable than the secondary or tertiary carbon ions. This is what called as Hoffman's rule. So in the screen you are seeing the Hoffman elimination. Hoffman's elimination applies to cases where the quaternary nitrogen compound has several different alkyl groups attached to nitrogen as in the following. So in the product, least highly alkylated olefin that could be formed. There is another important distinction between quaternary ammonium compounds and alkyl halides. Under a given set of conditions, the former prefers to undergo E2 elimination over S-enter substitution. The substitution reaction occurs in those cases where there is no hydrogen available for elimination, as the following example. Now, let's talk about the factors influencing the course of elimination reactions. There are many factors that will affect the elimination reaction. The first one is effect of substrate. In the substrate structure, OHCH groups attached to the alpha or beta carbon atoms affect the course of the reaction. They may affect in several directions. Example, they may stabilize or destabilize the double bond, the carbon ion, the carbocation, or they may be exert steric like eclipsing effect. The steric factors are most marked in E2 eliminations. The carbocation stability is not applied in E1 just as carbocation stability is not applicable in E1 reactions. Groups like AR or C double bond C, whether present on alpha or beta, always increase elimination by any mechanism. Electron withdrawing groups like bromine, chlorine, cyanide or NO2 increase the acidity when present in beta position and enhance the rate of E2 elimination. The alkyl or aryl, since they stabilize the carbocation in the transition state, always favor E1 elimination. Beta alkyl groups, since they decrease the acidity of hydrogen, also favor E1 reaction. Beta aryl groups, by stabilizing the carbon ion, shift the mechanism towards E1CB mechanism. The next one, attacking base. The effect of attacking base is also a predominant one. In E1 mechanism, an external base is not required. The solvent acts as a base. But if some external base is added, the mechanism shifts towards E2. Stronger bases and with increasing concentrations shift the mechanism from E1 to E2 and to E1CB. Although E2 eliminations occur with a number of bases, those with the preparative importance are OH, OR and NH2 using conjugate acids as solvents. In the first order reactions, if the carbocation partially decomposes before collision with an anion, the ratio of elimination to total reaction should depend upon the structure of the carbocation. For a number of compounds of the general structure Rx, this has been found to be true regardless of whether X is chlorine, bromine or iodine. Using bases of higher concentrations, the proportion of olefin formed will again be almost constant, since the ratio of products will depend upon the ratio of the respective rates of formation. Amount of olefin is equal to rate of olefin formation. So this will be given as Ke by Ke plus Ks is equal to K, where Ke may be designated as specific rate constant for elimination and Ks will be designated as specific rate constant for substitution. This means that strong bases favor the formation of olefin as against substitution, and using high concentrations E2 predominates over SN2. Conversely, at lower concentrations of the base, SN1 predominates over SN2. So these are certain prevailing conditions in which whether the E2 or SN2 or E1 or SN1, which reaction predominates is a case of interest. Now let's talk about the effect of the medium. The effect of an ionizing solvent upon the course of elimination reactions is deduced by considering the distribution of electrical charge in the transition state of different reactions. It has been shown that for neutral leaving groups, E1 and E1CB reactions are favored by increasing solvent polarity and by increasing ionic strength. Dimethyl sulfoxide favors E1CB elimination. Increasing solvent polarity favors SN2 over E2. For example, we know that alcoholic potassium hydroxide gives elimination, while more polar aqueous potassium hydroxide gives substitution reactions rather. Now we will see about the effect of leaving group. The leaving groups also considerably affect the course of elimination reactions and the process is similar to nucleophilic substitution. The leaving group may be broadly put into two classes: those favoring E2 reactions like OCO, fluorine, chlorine, bromine, iodine, and cyanide. Those favoring E1 reactions like NR3 plus, OH2 plus, ClBr, and iodine. The OH2 plus is used for preparative purpose. Better leaving groups favor E1 reaction due to easy ionization. Positively charged leaving groups favor E1CB mechanism. So far, we have discussed the distinguishing feature of E1, E2 and E1CB mechanisms, and we have discussed something on the orientation of double bond, and we have seen the factors that will affect the course of the elimination reactions. The remaining things we will see in the next video lesson. Thank you so much.